Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the final temperature of a sample of CO2 gas of mass 16.0 gram that is expanded reversibly and adiabatically from 500 centimeter cubed at 298.15 kelvins to 2.00 dm cubed. The first thing you have to note is that we're told that this is a reversible adiabatic expansion problem. So anytime you have questions like this, you make sure you remember that you're going to be dealing with a specific formula for this question. But before we discuss the formula, let us write all of the parameters that we're given. We're given the mass to be 16.0 grams. We're given the initial volume. Hence, we're told from 500 centimeter cube to 200, to 2.00 decimeter cube. So the initial volume is 500 centimeter cube. The final volume is 2.00 decimeter cube. And we're also given the initial temperature to be 298.15 kelvins. And we're also given our, that's all we're given actually. We're now told to find the final temperature. So what we're actually looking for is T final. So since this is a reversible adiabatic expansion, right, you're going to be using this particular formula I'm about to write, which is the final temperature is equal to the initial temperature times V initial, okay, divided by V final raised to the power of 1 over C. So we've gotten the initial volume, the final volume, and the initial temperature. So we have three parameters in this particular equation. But the only issue is that we don't know what C is. So if you don't know what C is, you're going to have to like determine what C is in order for you to properly substitute the values and solve this question. But before we go on to determine C, we have to observe that we're given one of our temperature questions in 500 centimeter cube, and the final volume we're given that in decimeter cube. So what you have to do is to first of all convert 500 centimeter cube to decimeter cube, or you can go the other way. You can go from decimeter cube right to centimeter cube, or from centimeter cube to decimeter cube. The most important thing is for you to note that the volume has to have consistent units, meaning the initial volume and the final volume have to have the exact same unit. In this particular case, I'm going to be going from centimeter cube to decimeter cube purposely for this particular question. So to go from centimeter cube to decimeter cube, you have to note that 1 decimeter cube is the same thing as 1000 centimeter cube. And we're given the V initial to be 500 centimeter cube. So we're going to put 500 centimeter cube right here. And we're going to put the unknown X. Basically, we're trying to go from centimeter cube to decimeter cube. Of course, you cross multiply to know what the value would be for X. And what you end up with is we're going to end up with 1000 centimeter cube X equals to 500 centimeter cube decimeter cube. Of course, you can cancel out the centimeter cube because those are the units that are consistent on both sides, and X ends up becoming 500 divided by 1000 decimeter cubed. Of course, with some simple calculation, we see that this is going to be 1 over 2. So X is actually going to be 0.500 decimeter cubed. So that's basically what the V initial is in decimeter cube. So we can just rewrite our V initial here up top to be 0.500 decimeter cube. Now, the next thing we're going to do is for us to determine the value of C, right? We have to determine the value for C. We know that that's very, very important in order for us to like input all the questions here successfully. So to find C, we have to note this information right here. Let me erase this work so that we don't have to go too far. So to find C, we have to note that the formula is CV, M divided by R. So this is the molar heat capacity at constant volume, as well as this is a gas constant. So we know the molar heat capacity of this particular question, CO2 gas, is going to be 28.2 joule per mole Kelvin. And now you may be wondering, this information was not given to us in the question. Like the molar heat capacity at constant volume for CO2 gas was not given. Well, if you have your textbook, you can go to the resource section of your textbook and you'd find this value, or you can just simply Google the question. sorry, not Google the question. You can simply Google what's the molar heat capacity at constant volume for CO2 gases, and they're going to give you that value. So CV, comma M divided by R, and R is just 8.3145 joule per mole Kelvin. So when you have that, of course, you input your information in the calculator to get C equals, let's cancel out joule, mole Kelvin. So that'll be 28.2 divided by 8.3145. And that's going to give you 3.392. So that's the value for C. Yeah, that's the value for C, and that's what we're going to be inputting in this information. Now we've gotten C, we have our T initial, our V initial, and our final volume. So inputting our work in the calculator, sorry, inputting our information in the equation, we have T final is equal to 298.15 Kelvin, okay, times the V initial is 0.500 dm cubed, okay, and then our V final is simply 2.00 dm cubed. All of that information raised to the power of 1 over C. And then C is just simply 3.392. So 3.392. So T final is going to equal this. Before we go ahead, let's cancel out the units for the volume. And we're going to input this information in our calculator to get, I'm talking about this information right here. We're going to input that information in our calculator to get 0.66436, okay, times 298 kelvins, 298.15 kelvins. When we input this information in our calculator, we end up getting 198.0779 kelvins. And as you can see, our question for initial temperature was given to us in 2 sig figs. So we end up putting this information in 2 sig figs. So the T final ends up becoming 198.08 kelvins. So this is in 2 decimal places, just like our initial temperature was given. Now, it is also possible for you to write this in 3 sig figs, because the lowest number of significant figures in this question, as we can see, 2.00500 as well as 16.0 are all in 3 sig figs. Maybe that your professor or your teacher, whoever is marking your work, wants you to write in 3 sig figs. So if you have to write it in 3 sig figs, what you end up with is just 198 kelvins. And that's going to also be the answer for 2 final in 3 sig figs. So I wish you guys all the very best. If you're a student who wants to succeed in all your STEM related courses, whether you're in middle school, high school, and college, make sure you email me at shohabitutoring@gmail.com. I help students succeed and be the best versions of themselves in their academic career. I also help mentor students who may be struggling in any area of their academic life. So if you would like to book a service, make sure you email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.